Hello class, and welcome to section 7.7, which is about factoring special cases. By the end of today's lesson, you'll be able to factor the two kinds of special cases, which are difference of squares and the perfect square trinomial. So just like when we were doing multiplication of polynomials, we had some special pieces that we looked at in section 7.3. We're doing that same kind of idea now with factoring. So looking at ones where we can kind of observe that they're special, and then use a shortcut for. The first one is called the difference of squares. So this is when there are two perfect squares being separated by a subtraction sign. Hence, subtraction is difference, perfect squares is square. So the equation for this would be something squared minus something squared. This is the one we can break up into that thing minus the second thing, and the first thing plus the second thing. So when we were in section 7.3, it looked something like this. And then we worked and we got our answer of 4x squared minus 9. Now we're starting with this and moving back up to that factored form. Couple things that I want to remind you of when I'm talking about a perfect square, I mean numbers that have an integer square root. So, for example, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are all factors that you should know, such as 8 times 8 being 64. The other three that I'm going to encourage you to remember are 169 is 13 times 13, 196 is 14 times 14, and 15 times 15 is 225. So if you can make a conscious effort to memorize these 15 perfect squares, that's going to make your life a lot easier when you're looking at these special cases. So when you are doing a difference of squares case, the first thing you need to check is, are there two things being subtracted? If it's addition or if it's more than two things, this is not going to work. The next thing you need to check is the first part a perfect square? Both the number and the variable would have to be a perfect square. And is the second part a perfect square? Again, both the number and the variable would have to be a perfect square. So, if we're looking at 49x squared minus 25y squared, first thing we check, is it subtraction? The answer is yes. Second thing we check, can I take the square root of 49? Yes, the answer is 7. Can I take the square root of x squared? Yes, that's an x. Our last thing we need to check, can I take the square root of 25? That's 5. Can I take the square root of y squared? Yes, that's y. So because it's subtraction and I can take the square root of both options, my final factored solution here is going to be 7x minus 5y and 7x plus 5y. So we take it, one is positive, one's addition, one is negative. You could take this positive term and put it in the front if we wanted to, or you can leave it in the back as I had it written. It doesn't matter the order of the positives and the negatives. Go ahead and try this one on your own. Again, you can square root the front, you can square root the back. They're being separated by subtraction, so we have 1 minus and 1 plus. The next option for our special cases is going to be what we call a perfect square trinomial. So that is a trinomial, a three-part thing that is the result of a square of a binomial. So this was our other special case in multiplication where we had AB times AB, where it matched, that squared part, or AB minus AB times AB minus AB. So that's that matching piece. So how do we go about determining if a trinomial can use the shortcut? Step 1, check to see if the first term is a perfect square. So can you take the square root of the first term? Check to see if you can take the square root of the back term. That's our second step. The last thing that you want to check is the middle term equal to twice the other two terms? That step 3 is the part that people usually forget about with this. So I'm going to go through and show you what that means now. So we have 69x squared minus 52x plus 4. So our first thing to check is the first term a perfect square? The answer is yes. We can take the square root of 169, that's 13. The square root of x squared is x. Then we jump to the back, and we say, okay, the square root of 4 is 2. Now what I need to do, that third step that I was saying people usually forget about, is check if I do 13x times 2, and then I double that. 13x times 2 is 26x, times 2 is 52x. That is then matching the number in the middle. Now you might notice, mine says positive 52x and the middle says negative 52x. That is okay. What that then means is that when I write out my answer, it's going to be 13x minus 2 squared. If this had been a positive 52, then that would have been a plus 2 in our final answer. If this had been something like 62 instead of 52, then we would not be able to factor it because this middle piece has to be twice as big as those outside two combined. So again, square root the front, square root the back, that's where this part came from, and then when you multiply those together and double it, it should be the middle term. When you are deciding if this is addition or subtraction, it depends on the sign of the middle term. Go ahead and try this one on your own. Square root the front is x, square root the back is 4, x times 4 is 4x, times 2 is 8x, that matches the middle. The middle is a positive, so we have x plus 4 squared as our final answer. Again, we're going to go through and try another one of these. We're going to say the square root of 3 is 9, square root of x squared is x, square root of the back is 25. Now when I go through and check, and I say I've got 3x times 5 times 2, that gives me 15. That should be an x, so 15x times 2 gives me 30x. That does not match the middle term. So if it happens where the front can have a square root and the back can have a square root, but the middle term does not match, this is an example of what we would call prime. So that's not factorable. We can't break it down any simpler. So this is a prime trinomial. Another thing that you might need to do is to look if there are multiple variables. So we've got our x squareds here and our y squareds here. We're still going to go about this the same way. We're going to look and say, can I take the square root of the front? Yes, I can. It's 8x. Can I take the square root of the back? Yes. That's going to be 6y. You're still going to then follow that same portion in the middle. 8x times 6y times 2. 8 times 6 is 48, times 2 is 96, and then we have 96 with an x and a y. That does match our middle term. So our final answer ends up being then 8x, middle sign is plus, so plus 6y squared. One thing I forgot to mention earlier is you can write it as a square, or if you wanted to write it out as 8x plus 6y and 8x plus 6y. If you wanted to write it out twice, you could. The shorthand is just to write it with the square power. Go ahead and try this one on your own. So when I solve, square root the front, square root the back, check out the middle term. It is a subtraction in the middle, so we have 9y minus 4z squared. Another thing you want to do, so we're looking at this one right now. We have 5nx squared minus 30nx squared plus 45n. Right now, this does not look like a perfect square trinomial because we can't square root 5. But one thing you might need to check on some of these problems is, can you take out a GCF, that greatest common factor, first? So if I'm looking here, all of these can be divided by 5, and they all have an n. So if I pull out 5n from the first part, I end up with x squared. If I pull out 5 and n from the second part, I end up with negative 6x. If I pull out 5 and n from the last part, I end up with just 9. Now if I look again, I can take the square root of x squared and get x. I can take the square root of 9 and get 3. And when I check the middle part and I say x times 3 times 2, that's going to give me 6x, which matches up with that middle. So then my final answer would become x minus 3, because we've got that minus from the middle. And then we have in the front that GCF, that term that we pulled out at the beginning. So we pulled out a term and then proceeded on to our special case. Go ahead and try this one on your own. In this case, the factor that we can pull out is just y. They can't all be divided by the same number. But once we pull out that y, then we end up with those perfect squares as the first and third term, and proceed down to get y, and then in parentheses, y plus, or 10y plus 11, close that parentheses, squared. Last thing we're going to look at is sometimes it's going to ask you to figure out how to make the perfect square trinomial. So we're trying to figure out what factor we could have in the place of b so that this is a factorable perfect square trinomial. So what we need to do then is look at the front, take the square root, so we get 12 and a, look at the back, take the square root, and then we need to go ahead and figure out what that middle piece would be. So 12a times 7 times 2. 12 times 7 is 84, times 2 gives us 168a. So the piece that would have to go in the place of b is going to be 168. Then if we were completing this, our final step would be to say that we would factor it down to 12a minus 7 squared. So that b value is 168. That final final factoring is 12a minus 7 squared. Go ahead and try this one on your own. So we again figure out those perfect squares, multiply to figure out what number would need to go in the place of b, and then we have our final factored form of 6a plus 9 squared. If you have questions about this or anything else from the lesson, please let me know when you get to class.